that have come into our state over the last 2 decades and are also an issue in Utah and pretty much anywhere, if not now, in the near future. The Japanese beetle and emerald ash borer. Let me start with the Japanese beetle, since that's the one I get most questions about. It is an insect that was first introduced in the United States accidentally on nursery stock that came from Japan in New Jersey. After that point, it spread rapidly along the East Coast, but then kind of slowed down as we went further and further towards the Mississippi River, and pretty much stalled on the other side of the Mississippi River for a long time. Now, this is an insect that I have more trouble discussing than any other insect on ornamental plants, and that's because it's really two different insects. It's the adults feed in one way, and the larvae feed in the other. The adults are going to feed on the leaves and flowers of a lot of common plants, and the larvae are what we call a kind of white grub, and they chew on the roots, and they can be damaging in both of these stages. But it spread slowly. But we look at a map that the USDA put out in 2018, and it has quite a few other states now that have confirmed Japanese beetle infestations. But now there are several states in the western U.S., including Utah, where you have infestations where the insect has established. Now, whether or not some of these will be eradicated is to be determined. But there are several states that have sustained reproducing populations. By the way, when that was a question in Colorado, when it first came in, we probably had dozens and dozens of introductions prior to 2000, but there was debate on whether it could even survive winter. And it wasn't until the early 2000s that it was confirmed they could survive winter. And after that, things started taking off. Now, this is a map of the whole state, and just kind of generally shows the area east of the mountains, where Denver is, where Fort Collins is, up in the north central part of this, and down in the lower part there's a Pueblo. Anyway, areas that have got red or yellow have Japanese beetle, and this is an old map. The numbers of Japanese beetle, for instance, in my town, Fort Collins, now have just skyrocketed since then. So we have some very heavy infestations. Also, in the last 2 years, there was a infestation that got established in Grand Junction area, and there are still efforts to try to eradicate that. Frankly, I'm not very hopeful that we'll be able to eradicate it. It's gotten too far, and we don't have enough resources for that. Anyway, so this is just how fast this thing can go when it takes off. There was one little snapshot that was done back in 2008, where all these little dots on this map are a Japanese beetle trap that was put out in a cooperative project with the Cooperative Extension folks, Department of Ag, and USDA APHIS. And you can't see all the details, but most of the light spots mean they got very little, if any, Japanese beetles back in 2008. And I've just got a little arrow on one of them, and that's a trap that was in an area that in 2008 got to about 1 to 9 Japanese beetles in the entire summer. And then when I went back in 2018, 2019, they were getting 1,000 Japanese beetles a day in the trend, from under 10 in a whole summer to 1,000 a day during the peak, which occurs in mid to late July. Now, this is an insect that, again, is damaging 2 different stages. It starts as an egg, and there are 3 larval stages that are going to feed on the roots, mostly of grass and irrigated grass. It has to be they survive only in soil that is moist. So this would be kind of one of the diagrams of this life cycle. And I think this is from a Utah publication, in fact. Anyway, the adults emerge in late June, early July. They are active until September, but most eggs are being laid in July. Then you have little grubs, and they get bigger grubs, and the bigger they are, the more they feed. Oh, and 2 different ways they're going to feed. The larvae nationwide, the larvae are probably the most damaging stage in terms of economic value. Damage to turf grass alone in 2015 was estimated to be $234 million a year in the U.S. Lawns are lost. A lot of insecticide is used on the lawns. That, however, has not been the main thing that people in Colorado are complaining about. They're complaining about the adults, but the larvae are building in numbers as the adults build in numbers. The white grubs will prune the roots, and their pruning will essentially cause a stress on the plant that causes it not to get enough water, so that they then start to dry down, and ultimately can be killed if you have enough sustained root pruning. The other thing that sometimes is the first heads up that people have white grubs in their lawn. Japanese beetle would be the only white grub they have in their lawns in many parts of the state now. Is it's attractive to some big predators at night. So if you have a lot of grubs in a lawn and you have skunks or raccoons, they will come out and they will dig lawns. So sometimes people first learn about this when they see their lawns being dug up. Now, the adults lay eggs in the ground that are going to hatch into those grubs. So the adults are very sensitive to where they will lay eggs. So they won't lay them just anywhere. They have to lay eggs in soil that's suitably moist. If it's not suitably moist, they won't lay eggs there, or the eggs that they do lay will perish. Two stages of Japanese beetle are really susceptible to drying, and that is the first stage larva, first stage white grub, and the egg. And if eggs are laid in soil that then dries, then it dies, or the first stage larvae will die. They're susceptible. And I think this is one of the reasons why if you go to the east, where this insect has been common for so long, you will have years where there's lots of Japanese beetles, adults that are around, and people notice them. And then another year when there's very few. And I think the primary reason for this has to do with the soil conditions the previous year. So if it was a nice moist July in one year, then the next year you'll have lots of beetles because they'll survive well. But if it's a droughty summer, you will have few beetles the next year. So here we have, excuse me, get rid of this. Anyway, here we have a different situation in that we have irrigated turf grass. So essentially, we have conditions that are favorable to Japanese beetle every year in these turf grass areas. So these early stages, late June, excuse me, the critical stages, late June and July. If it dries out, then there can be a lot of mortality. And this whole issue of soil moisture being important, the location of Japanese beetle in the state is going to be associated with areas of a large amount of irrigated turf grass. If you don't have large amounts of irrigated turf grass, this is not going to be a problem. In rural areas, this is not going to be a problem. In urbanized areas, it's going to be a problem to the extent that there are large amounts of irrigated turf grass. When the Japanese beetle first came into Colorado, there were two areas in the Denver metro area that had high populations of Japanese beetle, relatively speaking. And those were both golf courses. And people then went and blamed, Cherry Hills Cherry Hills Golf Course or Denver Country Club for bringing Japanese beetle. There's no way to prove that they brought Japanese beetle in, but what golf courses will do is they will amplify Japanese beetles because it's a big area, a lot of turf grass, perfect site for them to develop. Also parks and areas in neighborhoods that have got big green belts that are irrigated. Those areas have the greatest problems. If you're in an area with little irrigated turf grass, this is not an issue. And if it dries out and you have dry lawns, then you'll probably have fewer grubs developing in that lawn than one that is irrigated. But most people in Colorado are complaining about the adults, highly visible, good looking insect, but highly visible in your face, feeding on some very popular kinds of plants, and not only just feeding on the leaves, but feeding on the flowers. If they're feeding on the leaves, they're going to cause a kind of condition that is pretty unique. It's called skeletonizing, where the adults will feed between the veins, kind of leaving a skeleton, and that's shown best in the picture in the lower right. So this is a kind of injury that very few insects do in our area and in Utah as well. And so actually one of the ways, if I want to know if Japanese beetle has gotten into a new neighborhood, I'll walk over and look at a Virginia creeper hedge and see if there's skeletonizing on the leaves. If there is, that area has Japanese beetle, almost without any exception. But they also feed on flowers of many plants, and flowers might be the more favored part of the plant. And as a result, this brings up one of the biggest problems with managing Japanese beetle. And that is, how do you manage an insect that is feeding on flowers that are concurrently at the same time being used by pollinators? Because you can't use most any pesticides on a plant that is in bloom. And we'll talk about two exceptions that can be used, but most of them are not usable against the law. It's illegal. So the kinds of plants that are getting hit the most, I would say the uber hosts here in Colorado would be roses, some of the lindens, Virginia creeper, and silver lace vine. So those would be the ones where if I want to know if Japanese beetles in an area, I'll go look for those plants and see if I'm seeing skeletonizing or the beetles on the plant themselves on the flowers, like in roses. But there's others, hollyhocks, rose of Sharon, crabapple in the east is generally considered a highly favored one. I put it on the list, but I've never seen serious damage in Colorado on crabapple. Anyway, some food crops: beans, raspberries, grapes. Anyway, now one thing that the has been done here is Douglas County Extension has coordinated an effort to try to list the relative susceptibility of all the common plants that they're growing around here, and to see to susceptibility to Japanese beetle. And it's a long list. They have annual flowers and perennial flowers and trees, and some of them are not damaged, and some of them have moderate damage, and some of them are heavily damaged. Sometimes it's on the foliage, sometimes it's on the flowers. But this is a continuously updated list, Douglas County Extension, Japanese beetle host plant list, where you can see what are the plants that are being damaged here in Colorado. And it's a little different than the East. Also, even if there's just one plant, you take rose and a gazillion kinds of roses. And one opportunity we've had here is to look at whether there's differences in susceptibility to Japanese beetle in different kinds of roses. We have a War Memorial Garden in Littleton, which is south of Denver, over 150 different kinds of rose cultivars in replicated plantings. And over 2 years, we went down there and made observations where we would rank them 0 to 3 in terms of damage by Japanese beetle. And then we would also rank them 0 to 3 whether or not bees were visiting them, because some roses are not very attractive to bees, perhaps because they've got a double blossom or some other character, and some are highly favored. And there were some roses that we never saw damage to in that site. And when we plot out all the observations that we have bee visitation from 0 to 3 on the bottom, and we have Japanese beetle damage from 0 to 3 on the left side. And you can plot it all out. And what we have are different kind of cultivars. The ones that have large numbers of bees and large numbers of Japanese beetle, those are going to be ones that are going to be really tough to sustain in a post-Japanese beetle world. You can't use many insecticides, and it's heavily damaged. Some have very little, like on the far left, have very little visitation by bees. And if the bees aren't visiting, you don't have pollinators visiting the crop, then there might be more options. Another, and in the bottom would be cultivars that Japanese beetle just doesn't damage. So most of them are right in the middle, but there are some at the edges. And again, we have this problem of how do you use insecticides if you have to on a plant where that is being visited by mostly bees when we're talking pollinators. And we'll come back to that again. The other thing with the traps, the other thing with Japanese beetle, one of the difficult things to communicate is the use of Japanese beetle traps. There are traps for Japanese beetle that are astonishingly effective. I mean, they have a lure, a 3-part blend that is highly, highly attractive to Japanese beetle. And basically a trap will be some kind of vein trap that has the lure in the middle, and they will be attracted to the lure, bang into the trap, baffles, and fall into the bottom. These are extremely effective at catching Japanese beetles. But the separate question is, are they effective for controlling Japanese beetles? I mean, it feels great. You can get a bag full of Japanese beetles, but are you really helping? And the truth is, no. If you have if you've got Japanese beetle widely established in the area, Japanese beetle traps can't help you control them in your yard anymore. And that's because they bring in more beetles into the vicinity of the trap than the trap will catch itself. So you can actually have more damage on plants that are near a Japanese beetle trap than if you didn't have a Japanese beetle trap. So this is a pretty lousy little video, but and it's not from Colorado, it's from Ohio. But anyway, I mean, just think you can see this homemade trap just filled with Japanese. It doesn't get that bad yet here in Colorado, but they just come in from blocks away. By the way, if you're going to be working with Japanese beetles in traps, you might be trying to count the number of Japanese beetles in a trap for some reason to monitor are their numbers getting higher. We tried that for a little while, and it takes so much time. So what I suggest is count them volumetrically, and we estimate there's 836 Japanese beetles per cup. So you can just pour it in a volumetric flask and then see what the volume is and estimate the number of beetles. And that's what I would suggest. But if you insist on using a Japanese beetle trap, what I tell people is don't put it anywhere near at least 30 feet away from any plant on which Japanese beetles will feed. So you could put it on a pine, which they're not going to feed on, but not something that they are, because they'll be concentrated on those. And second thing, avoid placing them in a site where they are likely to draw beetles in from long distances. I'm thinking of people who put one on the edge of their yard and they've got a green belt maybe in their backyard, and they just suck them right into the yard. If you insist on using a Japanese beetle trap, preferably anyway, you'll get more benefit from it if your neighbor has it than if you do. So we have a Japanese beetle general fact sheet on this that you might find useful. And a lot of it gets into this insecticide issue. Oh, there are many kinds of chemical controls that can control adult Japanese beetles. The most pyrethroids, they'll give you a week or maybe even 10 days control. Carbaryl, although you can't find that anymore, and a couple of other insecticides, including imidacloprid. However, if you look at this list, essentially everything in terms of chemical control that are allowed to be used or that can be effective against Japanese beetles adults cannot be used if there are bees visiting the plant, if the plants have flowers and are being actively visited. So you cannot treat it. It's not legal. It says it on the label. So there's very few things that are allowed. The one chemical insecticide that is allowed is something called, on the trade name, acelepryn. Active ingredients called chlorantraniliprole, a big mouthful. But this is a pretty remarkable, different kind of insecticide. When it first came out, there were a couple things that impressed me. One is it has extremely low hazard to bees. Another is that it's very effective against beetles and caterpillars in particular. The other thing is it not only doesn't have any warning signals for pollinators, the hazard rating of this is a category 4. Now, I didn't know there was a category 4 before this. I mean, category 1 has got danger, poison on the label. Category 2's got warning on the label. Category 3's got caution on the label. Category 4, wear socks and shoes. I mean, I think that's it going in the right direction in terms of toxicity and a product that toxicity and hazard of a product that we use in and around where humans and vertebrate pets are common. It is extremely expensive. It is not marketed to homeowner packages. I think a pint of the active ingredient I just looked might cost $500, but you don't use very much. Anyway, but the other one that we have is a microbe that hit the market 4 or 5 years ago. I'm not sure. It's a new strain of a bacterium called Bacillus thuringiensis. The new strain is the Galarian strain, and it's sold as Beetle Gone or Beetle Juice in various markets. Now, BT, Bacillus thuringiensis, BT, there have been strains around since the 60s at least, and they're all derived from this microbe, Bacillus thuringiensis, which occurs in the soil. But this microbe has different strains that produce different compounds that can be insecticidal. And these have been identified, and there are different strains for different kinds of insects. In terms of something like a beetle, how it would be used, it would be sprayed on the foliage. And if the beetle feeds on that, or a caterpillar feeds on it, then they will ingest some of the BT. And what it then does is it paralyzes their gut. Their midgut is paralyzed. So the larva stops feeding almost immediately and growth stops. Doesn't die immediately, might take 2 to 5 days or maybe even longer from gut starvation or the destruction of the gut lining of the insect. But that's how it works. It's a stomach poison, has to be eaten to be effective. And there are different strains. In the past, we've had beetles, we've had strains for caterpillars, strains for leaf beetles like elm leaf beetle or colored potato beetle, and then ones for gnat types of flies like mosquitoes and black flies. BT galerii is the one that is on the market now, goes under Beetle Gone. I did test another formulation of it, the beetle juice, early on, treated foliage, held the foliage for 2, 3, 7 days, and then fed it to beetles. And I was quite impressed. I didn't expect a BT product to work as well as it did. I mean, it's not perfect. It's not, you got to reapply it probably at least every week, but it provides good reduction in feeding injury by Japanese beetles because they stop feeding almost immediately. Provides fair mortality, and the mortality is slow. They don't die quickly. And persistence effect is probably a few days, again, maybe as long as a week, which is long for a BT product. There are no bee hazard warnings and use restrictions, none. You can apply this on plants in bloom when bees are visiting. Also, it's certified organic too, so you could use it on certain kinds of veg crops. But after application, when you look, are they dead? They're probably not. But are they still feeding? Probably not. And that's the most important thing. So they're not going to die in front of your eyes, but it will have some effect fairly quickly. So I do have other resources that I provide in Colorado, little cheat sheets on the use of different insecticides for adults and different insecticides for larvae. Anyway, I can make those available if anybody wants to contact me on that. And then yes, this would be the larval sheet. Also, I do have one other reference that I've got to update a little bit, but it's questions and answers about Japanese beetle. I get so many questions about Japanese beetle, and it takes so long to talk about that I wrote this. It's over 25 pages long, and it tries to answer every question that people have ever asked me about Japanese beetle, so I don't need to talk about it again. Well, that hasn't worked, but anyway, it does help. However, where I think we are now, in our state anyway, where we have Japanese beetle established, we're not trying to eradicate it except maybe in the West Slope now, Grand Junction, but the rest of the state, we have it. Now we have to deal with it. There's not a possibility we can get rid of it. It's here to stay. So what we are emphasizing now is the idea of bringing to Colorado some of the things that attack Japanese beetles in other parts of the country, but didn't come to Colorado. Just the beetle came, not the things that attacked them in Kentucky or Minnesota or Massachusetts or wherever. So that's and the Japanese beetle does have a lot of natural enemies that they have tried to introduce, and a couple of them have been introduced. This started back in the 1920s, where they went to the native land of the Japanese beetle and found out what was attacking it there. And again, the first efforts in this were made back in 1927, I think, the first efforts. Anyway, but this is I'm going to skip that. But for the Colorado Japanese Beetle Biocontrol Program, we're looking at trying to introduce 3 organisms that will attack Japanese beetle and Japanese beetle alone. And there are actually 4. The one that I'm not going to talk about is milky spore, which is a well-known in the literature popular literature, biocontrol of Japanese beetle, but in more recent evaluations has been found to be very poor in terms of giving good control. Basically, what we're looking at are three things. One is a fungus called Ovovesicula papillae, which there was a common name. Then there's a little fly that attacks the insect. And then there's a little kind of wasp that goes into the ground and lays its eggs on Japanese beetle larvae. I'll just talk about these two middle ones. The one that I think has the most potential and what is most advanced in terms of what we're working with is the Ovovesicula papillae. It's again a kind of fungus, a microsporidian, which is now a fungus. They used to be protozoa when I went to school, but now they're fungi. Anyway, what it does is it infects a specific organ of the Japanese beetle, and that's what's called the Malpighian tubules, which are little tubules that float in the blood, in the blood that's bathing the body, and it acts essentially like their kidneys. It removes waste, and this interrupts the function of the Malpighian tubules. The main observed effects of this is from stress, so we get reduced winter survival of the larvae in the ground, shortened lifespan, and reduced egg laying by the adults. Now, this was moved into Michigan in the early 2000s, and most of the work then was done in Michigan State. And what they found is a 70% reduction in overwintering survival as we had increasing levels of ovovesicula infection of the larvae. They introduced it in the late 1990s, and over a course of about 12 years or so, they had a dramatic increase in terms of infection in the population. So perhaps about 35% of the beetles were infected. Concurrently with that, they over time had about a 70% reduction in Japanese beetle numbers. In southern Michigan, where they did this, starting in the 1990s, they have had a greater reduction, a substantial reduction in the number of Japanese beetles, which likely is largely associated with the establishment of this new fungus in the state. We introduced it here in Colorado from some beetles that were provided from those areas in Michigan in 2015 in two spots, one in Pueblo and one in Boulder. What we had were Japanese beetles that were shipped to us that were dead. They were frozen, dead beetles, and about 40% of those in the samples had Ovovesicula papillae. So we applied them in different ways, but the ways I usually do it is in a blender. So I'd get the Japanese beetles, buy this blender at the Goodwill. Couldn't use it for anything else, of course. Smells terrible, but blended it, mixed it with water, and then gets this little slurry, and then would put that on the soil. We also inserted whole beetles, broadcast the infected beetles, but the slurry works the best. And in 2015, we released it at two sites, and we got in 2017 positive infections confirmed after 2 years. Some of them, not a lot at that point, just 1 or 2%, but confirmed infestations, infections of this, which is really remarkable. And since then, this has been released at multiple sites. We have at least one confirmed site in Boulder where it's established, one in Pueblo, and probably 3 sites in the Denver area. So I'm going to skip this and get to the second natural enemy, and that is a kind of fly, sometimes called the winsome fly, or Istachita aldridgei. That's the scientific name. Glues its eggs on the back of Japanese beetles. The egg then hatches. So there it is, laying eggs. Egg hatches, the larvae go into the body and then kill the beetle, usually within about 5 days after the egg is laid. So we are still trying to establish this. It's one of the things that's limiting to this insect being effective is that it requires nectar in order to survive for very long, and the nectar has to be from little flowers that are accessible, something in the carrot family. So that's the kind of flowers we will need to have more of in the landscape to support this kind of parasite. But it has been released in multiple sites. We have not yet got a positive infection, a positive establishment confirmed anywhere. But good news for me is I found a great spot to collect. When I go back to St. Paul and visit friends there in July, I can collect Japanese beetles, and there over 30% of the adults are parasitized. Anyway, this biocontrol program is successful. What might be a good end result? I tell people it's not going to go away, but in 10 years, instead of 10 Japanese beetles on your rows, maybe there's only going to be 2 or 3. That would be great. That's success. Okay, now let's move to the second one, emerald ash borer, which I would say is the single most serious insect threat to urban trees in the United States. It is not native to the United States. It's native to Asia and was first found in Michigan. Probably got there sometime in the 1990s. Colorado joined the EAB club when this tree here was found to be positively infected with emerald ash borer in 2013, September 2013. So we just celebrated the 11th anniversary of emerald ash borer in Colorado. Now, emerald ash borer pretty much is restricted to the east. In Colorado, we can see this little area in the middle. Those are county records at this time in May 23, where emerald ash borer is presently known in the state. Now, how might it play out here versus the Midwest? In the Midwest, I mean, it has just whipped through, done enormous damage, not to just ash in urban areas, but to ash that's growing in forests. I mean, it's a very important native plant in those parts of the country. But it has been much slower in terms of spreading here in Colorado than in the Midwest. And I think there's several things in play, and the same things would go for Utah. We've got geographic barriers that will greatly limit natural spread. We've got geography. Ohio doesn't have geography. We've got geography. There's large areas where there's not continuous corridors of ash. The ash will be in a town, and then there might be 20 miles, and there won't be any ash. And then we also have some other things that are going to be competing with ash that may interact negatively, for the most part, with emerald ash borer. So when emerald ash borer gets into a state, when it gets established in your state, like here in Colorado, it got established in Boulder in 2013. Probably was there 5-6 years before, but 2013 when we found it. It'll either spread on its own, and if it's going to spread on its own, it'll be from winged adults that are flying. And the peak periods when these adults fly is late May through late July, or buttheads, idiots that move wood containing developing stages, which is how it got to Colorado in the first place. Some butthead moved it from, I don't know, Indiana or Ohio or Michigan and brought it into Boulder. So emerald ash borers are likely going to emerge in the adult stage sometime in mid to late May. They're adults. The eggs will be laid in June. The egg laying will continue through summer. But we wanted to look, if the main way of spreading are adults flying, well, they're going to be wind assisted. So I made a map of took all the wind records during the days from May through August when emerald ash borer would be expected to fly during the daytime periods when they'd fly, and averaged it all out. And we can see that sometimes the wind this direction up in the mountains would be great. So they come out of Boulder, they go into the mountains and they're dead, or they go down here and that's more mountains. But the greatest tendency for the wind patterns coming out of Boulder is down to the southeast. So how has emerald ash borer tracked since it was found in Boulder? Well, there were some, just to the southeast again, there were 3 infestations to the north, and one was Longmont, and that was related to people bringing infested firewood, infested logs. It was a tree care company. Before we knew about emerald ash borer, they brought them to Longmont, and then Longmont got infested. Probably the same thing happened in Lyons. Not sure how it got up here. Just somebody's property probably brought some firewood there. But the great trend has been steadily to the southeast. So here's Boulder now, and these are the counties that have been found infested. We did get it north of Fort Collins in 2019. It is still, I don't think it's yet crossed the city line from the north, but it's certainly at the doorstep. But pretty far away from my house, probably 5 miles away from my house. And so this is the part of the state where the insect got in. Now, one of the things when we first got it that I made the point of trying to impress is, yes, Colorado's got emerald ash borer, but Colorado, we've geography. We've got big mountain ranges that would impede the movement of this from one, and I generally think of this as river drainages, from one river drainage area to the next, or again, large areas that are absent any hosts. So I was always arguing that yes, in 2013, Colorado had an infestation of emerald ash borer, but Colorado as a whole is not infested, just the area, say the South Platte River drainage. And the same thing we'll be able to say for every single Western state. It may be found somewhere in the state, but that doesn't mean the whole state is at risk. In Ohio, you put it right in the middle of Ohio, and shoot, what's going to stop it? It can go in every direction. It's got lots of hosts, no geography to speak of, but not out here. It's different. 2023, last year, it was found in two spots where it had to have been moved by humans. One was south of Denver. It still has not been found in Denver, but people have been treating for 10 years, but it still has not been found in Denver. And Carbondale, it was found in Carbondale. And they go, Carbondale is a mountain town. It's pretty near Aspen. And they go, oh my gosh, now emerald ash borers in the West Slope. Well, emerald ash borer was just found right here in the middle of the mountains. I don't even know if it could get from Carbondale to Glenwood Springs, which is 20 miles away on its own. It's not like it's the whole county is infested. But if you look at this, just drives me nuts. So just a little rant here. When you look at records of where it is in national records, they have counties, whole counties, and this is all the county, Garfield County, that it's in this part of Garfield County right here, not the whole county. And we've got big counties. We've got counties that are size of Rhode Island, and if so, this is Weld County. It's the size of Rhode Island. It's found in this little corner of Weld County. That doesn't mean the county's infested. Anyway, we have these geographic barriers that will likely greatly limit natural spread. We lack the contiguous corridors of the host plants that will slow the spread, keep them isolated. Also, these other things that are impacting drought, freezing damage. I think one of the most important kinds of things that are caused by, or that we have here that have affected emerald ash borer are late spring freezes. I don't know how it is in Utah, but here along the Front Range, we got 30 degree day, 30 degree difference in day and night temperatures normally, and we can have extreme changes in temperature. We have warm springs, and then bam, it's -10, or 10 or whatever. Anyway, and oftentimes we get late spring freezes. And how does that affect emerald ash borer? Well, emerald ash borer, after it comes out of the tree, the adult feeds on leaves. It has to feed on leaves for a couple of weeks in order to mature eggs. And if it comes out and then it freezes and there's no leaves, it's going to starve. The other thing is emerald ash borer, when it is in the wintertime as a larva in the trunk of the tree, it is highly resistant to freezing. But at some time in the spring, it has to decide, is it 2025? Do I lose the antifreeze that I've been keeping to keep me through the winter? Do I become active? Do I move to the next stage? I pupate? Do I become an adult? And they do, because it's warm, and then boom, we get a Mother's Day freeze and they're dead under the bark. When that tree, that original tree in Boulder, when I pulled the bark off, it was full of adults, kind of like this picture on the left, that were dead. Had started to emerge, but that was a year we got a Mother's Day freeze, and they got hammered, and that knocks them back. So I think it eliminates the food used by these adults. It also, we have other organisms that compete with this, in particular wood-boring insects and some fungal diseases. Lots of wood borers in ash. At least two of them, I think, compete with emerald ash borer. We have big problems with ash bark beetles. Mostly they're found in limbs. They can be found on the trunk, or in larger limbs, but they are feeding on the same material that an emerald ash borer larva is trying to feed on. And if they get in there first, then they will eliminate the food that the emerald ash borer larva would have. There's also another flat-headed borer that we get in stressed trees and stressed ash trees called the flat-headed apple tree borer, and they will feed extensively again in the same area where an emerald ash borer might. So I think there's competition from other kinds of insects here.
Whitney, you may have looked at the time. We have about 10 minutes left.
Yes, I think I can hit it. So just a really good review of what's happened here in Colorado was put out this spring. It's called 10 Years with Emerald Ash Borer in Boulder. Excellent review. Talks about the kind of things they've been doing in terms of public tree plantings and removals. They have been the plantings of ash have gone down. They removed a lot of them that are either infested or ones that they do not want to keep and spend money on. And they've replaced them. They're replacing it, I think, at a rate of about 460 trees, 430 trees a year, new trees they're putting in. None of them are ash. 36 different species, trying to get a more diverse urban forest. Lessons learned section in this is excellent. If you want to know what Boulder has learned, they had a fantastic city forester on top of this. Last thing I want to mention is, if you want to control emerald ash borer, how do you define control? Will you be able to eliminate it from the state? How do you define control? Will you be able to eliminate it in the state or municipality once it's there? No, you won't. People have tried that. It's too hard to find out where it is. Once emerald ash borer is in, you can't eliminate it. You can manage it, but you can't eliminate it. Will you be able to slow its spread? Absolutely. And there's a program called Slow Ash Mortality, called the SLAM program, and that's used by foresters here to slow its spread. And will you be able to save individual trees? Absolutely. There are some great insecticides that can kill emerald ash borer. Some of them are very pricey. Some of them are less, they're not very pricey, but they are able to control this insect. Furthermore, they can control this insect even if the insect's been in the tree for a couple, 2, 3, 4 years, as long as it hasn't caused so much damage. I didn't show a picture of this, but the larvae feed on the underneath the bark, hasn't done so much damage under the bark that insecticides can't move, and that can take years. This is not something like Dutch elm disease where one beetle kills the tree. This is a progressive condition that is reversible. So if it hasn't, the emerald ash borer induced crown thinning, we get thin crowns from lots of things, but if it's emerald ash borer and the damage it's done is not progressed beyond about 50%, maybe 40, 50%, then insecticide can still cause recovery. There are different options. We do not treat for emerald ash borer like we do other borers, where we spray the trunk. Instead, we use systemic insecticides in the soil. There are 3 different ways we can use them as a soil application. One you can use as a trunk spray, and then trunk injections directly through holes in the bark. And we've got a summary sheet on these. Some of the insecticides work on the adults when they're feeding on the leaves, some on the larvae. There's different effects. Imidacloprid, for instance, works not on the egg. None of them work on the eggs, but imidacloprid doesn't work on late stage larvae, but does on young stage. The only one that works on larvae all stages and adults is emamectin benzoate. But anyway, they've all got positives and negatives. We have summaries of all of these in some of the fact sheets we've got. And again, I'd like to point out that there are lots of different products. By far, the most common one people are using is emamectin benzoate. It is the gold standard in terms of control. It can cause recovery if the tree is advanced and had some damage. It can come back and recover. However, imidacloprid is by far the cheapest and the only one homeowners can use. So I'm telling people, if they want to treat their tree, there are imidacloprid formulations out there that are legal to use that are a fraction of the cost, and homeowners can do it themselves.